Or in other words, welcome everybody to the first talk of Friday morning. Theo will be talking about system observability and distributed tracing. Welcome, Theo.
Hey guys, I'm trying to do my best here, doing something nice. Oh, you shouldn't see that, isn't it? All right, good. I hope this is all right, that you are seeing the right screen with this tiny Perceptix logo at the bottom.
Yep.
Awesome. Good morning for most of you in the US. Good afternoon for those in Europe, and welcome to this talk. I'm very excited about this. I'm also very nervous. This is the least prepared talk I ever gave. So be ready for some half-baked things. And having said so, let's start working on this. So this talk is about instrumentation and what you can do with OpenTracing and Datadog. So how did it start? It started with a guy from our company, Andres, that said, oh, Theo, can you make a change to our menu framework so we can get instrumentation into Datadog? And of course, what is your first response? Sure, I can do that. Yeah, Datadog. I'm not sure if you know what Datadog is and what it looks like. Datadog is pretty much a service, not a cheap service, but a very good service that gives you all these nice graphs and all these nice metrics about what your server is doing. And I think this is awesome if you are one of those sysadmins that try to figure out why your system is doing what it is doing or what it's not doing, what it's supposed to do. And it has all these nice dashboards where you can look at. It will tell you how many people are visiting your website. So the thing is that we were going to make some kind of instrumentation to this where you can actually see what the code is doing. And maybe a lot of you know a lot about NYT profiling. It will tell you in a very protected way what your application is doing, how long subroutines will take. But you usually don't do that in production because NYT prof, that profiler is taking a lot of time. It's an amazing tool, but don't run it in production. So there we go. First trial, try catch, no catch in this case. I started working on it and started looking. Everybody should do that. So you go to the CPAN, the not so comprehensive Perl archive. There is stuff about Datadog. And what else is there? I was thinking, maybe I can use log for Perl and send Datadog stuff to their backend. And I started writing an appender for HTTP. It didn't exist, but it's a useful thing. Another cool feature would be JSON formatter for Datadog. I started playing with DBIX query log. Very nice. And then I was thinking, you know what? Maybe I can extend that and start writing stuff that will then send this off to Datadog somehow. Because we were pretty much interested in what was happening with our database. Not so much in the code. It was just, why are our queries taking so long? Which queries, by the way, are taking so long? And we didn't know. Our application is one big black magic box. Sorry to say so. Did we hire, by the way? Anyway, so all nice modules, and you can start working on it. And I started getting headaches. So, Theo, this is not going to work. this starts looking like vendor login. And I don't want vendor login. I'm not sure if any people from Datadog are watching at this moment, but we like to be in a situation that with a single line of code change, swap the Datadog service for any of these competitors. And you start looking for, maybe there is a way to do it better. Hubris? Did Damien say that last night? Anyways, you start looking for it. And you know what? Try with a catch. And the catch is here. It's OpenTracing. OpenTracing is a marvelous thing. I say it's a thing. Actually, it's just an API. It's a description of how OpenTracing should work. What does it do? OpenTracing. OpenTracing, as they say, it's a so-called vendor-neutral set of APIs and instrumentation for distributed tracing. And it's awesome. Yes, use this, and there are plenty of solutions for Nginx, for New Relic, for Redis, for databases, for Django. So yes, go to the website of opentracing.io and you will find libraries in 9 languages. Like these, Go, JavaScript, and you know what? No Perl. Of course not. Who wants to have shiny tools in a legacy environment? So, yeah, where do you start? You start reading, and you get messed up. You get more headaches, lots of headaches. So there is a CPAN module on our not so comprehensive Perl archive called OpenTracing. However, it's nothing like OpenTracing. Sorry for the guys from team, but no, because OpenTracing starts with a API. And why did it start with an API? So that any code in Perl related to OpenTracing could work with that API. This is the complete opposite of we have with things like log_any. People started thinking, oh, we can make a logger, and then we got dozens of loggers in our not so comprehensive Perl archive. And yeah, now it's going to be a nightmare how to work with your own modules and which of the loggers. So OpenTracing is an attempt to do it just the other way around. Write your API first. And if you have that API, then all the modules can work that same way. This OpenTracing module did not start with that API, and it only works with Datadog. And no, sorry. It only works with, yes, it works with Datadog. Anyway, going from there, distributed tracing. What is distributed tracing about? Well, a normal application you will have will probably look something like this. You have a client, and you may have a load balancer that the request goes through, and from your load balancer, the request goes to a web server. That web server is probably using some kind of nice web framework. For example, a CDI. And if you have a CDI, and many other frameworks will have that in general, you will have a setup phase. After the setup phase, you start doing some processing of your work. Inside that work process, you may have some other tasks doing some work, more work happening in that process, even some other things there. You may do a database call. A lot of small tasks here, more work in the process. Maybe you call a microservice. Maybe that calls Redis. And then in the end, you do a render. Yeah, that's quite a lot involved. So yeah, that's where OpenTracing starts. You can start OpenTracing with where this client starts working. Then it goes to a load balancer, and then your application is typically responsible for this entire work. We're at a stage that your web server is doing all this work, and we'd like to do the other things as well. We'd like to do a database call. We'd like to monitor that one. We'd like to monitor that microservice as well as a kind of microservice, as a service. And all these distributed traces, that's where you want to follow this entire thing. And if you do it right, and this comes from Datadog, you will have this nice graph with all these flame graphs. And this would be real-time data. This is not NYT prof. This gives you deep insight in microseconds, or actually in nanoseconds accuracy, what your application is doing. So the API of Datadog, it has some concepts, and it's talking about a tracer, the responsibility of that tracer, how you want to extract information from an incoming request, and how you want to inject it into a outgoing microservice request. It wants to do things like start active spans, those tiny pieces of the graph you saw. We call it a span. You can enrich that span with some tags, maybe some information of how many records you're processing in that subroutine. It can have a context. The context is typically the application, has some specific stuff there. Very interesting of a context is a so-called baggage item, which will be carried over from every level of your call. It goes from one span to another span to another span, and it could even go into your next call of a microservice. It can be very handy if you're talking about client IDs. You do not need to add that as a tag all the time. And it speaks of scope. The API of Datadog, of OpenTracing, is very much relying on things like scope. When does the thing start? When does it end? And on hindsight, maybe the Perl version would not need it. So all these things, the concept of this API, you don't find it in the OpenTracing module. So how to get along with it? So I started all over. I started writing the OpenTracing interface. That is the reference of what I would think OpenTracing for Perl implementations and anything related to it. The entire thing I was just talking about, you can find it in the manual. It will have instrumentation. It will have integration part for people, how to work with a framework itself. It's talking about implementations in case like you want to have a different thing instead of Datadog. You want to have a New Relic version or a Elasticsearch. It's all possible in implementation. It's talking about the entire ecosystem. So with that, with the entire specification of OpenTracing, let's do this. Try finally. And I hope we did quite all right. As I speak, we just did the last checks. This code is super hot. It's has been beta alpha status for a long time. It's now beta. Next week it will be full version, whatever. so you can use it yourself. So, like I said, the menu was talking about instrumentation. How do you instrument your application? So what I would think is that you will have a CDI, in our case. Things would probably look the same for Dancer or Modulicious, which we haven't worked on yet. So a CDI, you just use the CDI application plugin OpenTracing, and that's basically it, I would think. And if you use this module, at the bottom, that's all you need to do. Maybe do some customization. You want to add some customer ID in your OpenTracing bagage items. Those will be carried over. And when you do this, you remember this stack we had of the entire OpenTracing distributed tracing. This is taking care of you out of the box. It will create that web framework. It will create the setup span. It will trace your timing of your process, and it will take care of the rendering and actually even of the teardown. It's giving a nice shim, sure, a nice shallow layer of your framework. And most of the time, if you would have a very well designed microservice architecture where you have just a server that gets a request from an incoming client, it quickly will dispatch to all sorts of microservices. Your server itself is not doing that much, and this will be perfectly fine. You don't need anything. However, our menu framework, our main application we're using with Perceptix, is a gigantic monolith of thousands and thousands of lines and hundreds of subroutines, tons of subclasses with dozens of subroutines inside them again. That's not helpful. It's not giving the information you want to have. So instead of just this shallow layer of our framework, we want to go on. So say you have a nice subroutine with some interesting work, and you want to trace the duration and anything else of this subroutine. How will you do that? Well, okay, let's expand this a little bit. It needs some room for some code, and add some code into it. It's a lot of boilerplate. It's like your interesting subroutine. You need a tracer. You will get that from the get global tracer. And then you will have your OpenTracing start a active span with a nice name of interesting work, add some options, and return that and save that in your scope variable. Then you do some work inside your subroutine, and at the end you call close on that scope. And you'll be done. And some of you will see a problem here. What if you would want to return early? Do I need to put in that OT scope close all over the place? Yes, you need to close that scope. That's part of your API. It will actually complain when you do not close it yourself. But us being Perl developers, in fact, we can do better. We can do much better. So let's have a talk about OpenTracing Autoscope. You may remember this piece of code we just had with all our manual work in there and, well, actually a lot of boilerplate here. It's annoying. It's like, that's way too much work. What about if we can just use this? Use the OpenTracing Autoscope module in your package. This was your subroutine, and this is what's left. Just one simple call, OpenTracing Autoscope, start guarded span. It will do all the magic for you. It will take the name of your subroutine and use that as the name of your piece of work you're doing. Options, the ones you need, are by default switched on. Still, you can pass in a different name if you want to. If you're not liking the name interesting work, change it here, add options, it's all there. But the best part is that the moment you are done with your scope here, you leave your subroutine for whatever reason, it will be nicely closed and it will be recorded to your tracer. So this was your stack. We had this one here, and with this Autoscope thing and with this manual tracing, you can now start adding more stuff into work spans and more. But it's still like, no. Perl can do much better. I had an interesting talk a week ago with a colleague of my son. He doesn't do Perl. He's doing a very interesting job and using all kinds of languages. He's very agile. He's very eager to learn stuff, plays a lot of things. He's a tinkerer and builds a very good company out of it. But his friend, interested in OpenTracing and programming in Go, he said, yes, you can do much better with Perl. The nice thing about Perl, it gives you access to everything, everywhere. So OpenTracing rep scopes is what you're looking for. Work in progress. Yeah, most of it is still work in progress. What does it look like? So we did have this thing here, your package, and we're using OpenTracing Autoscope. Get rid of it, change it for rep scope and the name of a subroutine, or a whole list of subroutines, or subroutines in another package. Yes, it will work. What does it do? Well, this was your subroutine. We had it with our Autoscope and start guarded span, and it works nice. This is how it will look like with rep scope. And why is this important? Because remember that subroutine we had in the beginning? That was exactly this one. And now we don't need to change the original code, which is super important. If you have hundreds of subroutines, you do not want to have a massive Git change that says all your subroutines are needed to change. It's like, no, we can do better. Don't touch your code. Just use this one call and it works. This was what we have with our framework, and with your Autoscope thing, it takes care of all these things here. And as we speak, I did say it was work in progress. I think it's finished. It's pretty much finished. And if not, then of course we will have updates and so more. Okay. This was about how to do instrumentation of your applications. About integrations, sadly, very sadly, DBIX OpenTracing is not done yet. But it's not going to be a very complicated task, and I'll explain later. But if you would do that, all your database queries would have an automatic span created with the tags, with your SQL statement, with the number of records returned, with all the nice things you like to have from a database call. The other one, HTTP headers OpenTracing. Yes, inject the span context everywhere. HTTP headers is the format we are using for extracting and injecting information and traces. CGI doesn't have HTTP headers, sadly. Yeah. Anyway, if you have this, your microservice is going to be taken care of by itself. Then, the roadmap. Yes, there is a roadmap. We want to have more open tracing implementations. We want to have Zipkin as one of them. And we want to have Elasticsearch. We want to have Jaeger. We want to have New Relic and anything else. The other one, the integrations, we want to have DBAX open tracing. We want to have Redis open tracing. Those two are taken care of soonish because we as Perceptics, we really need those ourselves. So those will be done soonish. Now, the entire ecosystem is way bigger. What about a denser integration? What about modulicious integration? Dylan, I know you're watching. Please reach out to me. Anyone from the Dancer team, reach out to me because we need to extend this. The CGI application is a huge thing. We use it in our legacy system, and all the nice shiny frameworks like Modulicious, they can benefit as well from it. But we needed it because our application, our service is getting slower and slower, and we want to know why. So that's why we have our legacy system with Datadog. It will show our bottlenecks soon enough. Contributing. Well, like I said, reach out to me. For open tracing, we did do some things like, yes, we did create types to make it easy. We love types. And then for testing, we created a test integration, which is the very simple way to create a span with a test tracer, have your integration do some instantiation, call some subroutines, do some dispatching, and then see what happened in the end. And your test tracer will show exactly what happened there. The interface, test open tracing interface, is just to make sure that whatever implementation you did build, it will adhere to the open tracing interface API, which will make sure that it doesn't break anywhere else. You needed that API. And that's about it. And hopefully soon everyone will have these nice graphs and dashboards. So I do still have 25 minutes left, 20 minutes left. That's pain because I had to figure out, what am I going to do? Am I going to work on my slides, or am I going to work on a live demo? I did work on my slides. And I did work on the live demo. But I am very careful on showing my screen, sharing my screen, and doing live demos. Maybe I can, if you like. I can do that. I can show you the real code, and I can show you how Datadog is actually reporting to us. I don't need to be frightened that I will expose any company details. So yeah, do I do that or not? I'm totally muted. I don't hear anything about you.
We're live.
Go live. All right.
Show us all the secrets.
Show the secrets. Okay. Let's see if I can do that. So this will be, all right, an empty screen. There you go. Yeah, good. You see that empty screen now with my nice desktop. And
yes.
Where is my Coda editor? Here's my Coda editor. And go for this one here. Not this one. Here. Good to go. This is very small, I'm afraid. I should have enlarged the fonts or changed the size of the resolution. Can I still do that without breaking stuff? Let's try. I probably will now break Zoom.
Alert.
There you go. Yes. You can still see the screen, I hope. So, this is a simple index CGI. This is how I wrote it. The thing itself, it says use base CGI application. The plugin, we're using OpenTracing Datadog. We have a thing called Global Tracer, just like log any, which gives you access to the tracer anywhere else, like here. You can just say your scope with that tracer. There are other ways to do it, safer ways to do it, because this tracer may not be instantiated yet. You will have undef, you don't want that. So what do we need? So this CGI has the setup phase here. If you're familiar with CGIs, this is where you do a lot of things to make sure that you can run whatever you want to run. Run modes. I don't know who invented it, but it seems to be a very smart thing to do at that time. I'm glad we have modern frameworks these days. Then a little bit of bootstrapping, like the service name we want to have. We have to set a type. We want to set the name of the resource, in this case, a simple index CGI. And here we have a OpenTracing Bagasse items. Now you can start looking at more code here. We have a do start thing that will be run. We have do something else that will sleep a little bit here and do something more. The do something more is here. And that's more or less our application. Fantastic, isn't it? Good. This one. There we go. Let's try to go here and say, what was it called? Simple? No. What was it called, our application? It was called Simple. Yeah, true. Simple index CGI. Hopefully it works. Well, this is do start. Amazing feedback we get here. We can change the run mode, I think. Say run mode is 9. That's amazing. Bye. We can do run mode is 1. And wow, that's a nightmare. Why? Oh, this is not good. This is just a typo. Live demos, I love them. And run mode is 1. This is taking a little bit because it has all these sleep statements in between, because we like that. Good. And now you're saying, well, that was nice, Theo. What with Datadog? Well, here's Datadog. This is our Datadog thing. I go back to our applications here. Let's see what's happening here. We have some services. We can browse through our services. Can we? Good. Here is our service again. A nice graph of the timeline. Here's the timeline. We see some spans showing up. We can click on them. We can see traces. Don't do this thing here. I want the entire application. We see here, nice status code. We see the run method called do something, do end more. So let's have a look in this one. Do start here. That's our nice graph we have. If we can zoom in a bit, we have this request here. We have the setup thing. We have a run span, and we have a tear down. Why only these three? Because this was a very simple way of doing the tracing and the instrumentation. We didn't do any fencing thing here. This was just what happens if you use the CGI application plugin itself. Now, that's boring. We did have another one. Where is this? Can I close it? When? Here, close. We had another one here. This was doing something. Let's have a look at this one. Oh, that was actually doing something here. Do something more. The spans are, here is a tiny setup span. There's a tiny tear down span, and the work stuff we're doing. It works. It's fine. All manual tracing. Now, go back to this thing here. Instead of simple, let's do Autoscope. Autoscope looks very much the same. Same way of setting up the stuff. But instead of doing the entire thing with adding stuff there, closing your scope, this should work as well. So let's have a look at Autoscope. Autoscope. Wow. Oh, yeah. This is one that's taking a little bit more, which we are interested in. Question is only, how long will it take before Datadog sees this? Looking at the timeline, 37, well, we need to wait a little. It will catch up soon. There in our span. Yes, we found it. View the traces. Not just the CGI run, but that entire thing. And, oh, where we go. See, I'm not a system admin. But here we got everything again. We have this do something span, which was created and closed automatically without doing any work there. As you can see, or maybe you can't see, at the bottom of this screen, you see still some interesting information about the method you got, the status code, the URL, the run modes we were having, do something, which is very interesting if you want to filter on. Some tags we added, some bagage items we added, so you can filter on client IDs or other things. And anything else you want to add to it. I think that's about it. I'm not going to show you the 68 files of code we had to write for this. Being lazy, hubris, I think it's just a way of you want to add instrumentation to your application. The one-line change should be enough. And what happens underneath is all up to you. No, it's all up to us, I would say. It's up to you how you want to look at it as a developer. But you shouldn't care about it. And I think with this way, adding OpenTracing to your application, you can quickly see what your application is doing, where the bottlenecks are, and like I promised, you will gain back zillions of nanoseconds soon enough. I think that's about it for today.
Awesome, thank you.
I must say, by the way, a huge thank you for Perceptics. I must say that, because they have been waiting for a long time. I mean, for a long, long time to get this stuff up and running. This is not a side project of myself. This is a fully paid project by Perceptics. Hundreds of man hours in it. Also a very great thanks for Simon, who is helping me with the deeper dark voodoo stuff in autoscoping and Wrapup stuff, writing tons of tests, making things much easier. And thank you for the Perl community for allowing me to speak to you. And thank you for listening. Any questions?
I'm going to clap.
You're allowed to.
I have a question, Theo.
All right.
So this is very cool, first of all. It's essentially profiling a production application, a live application. And one of the issues that you mentioned with just using NYT-Prof, for example, is that it's extremely load intensive. It takes a lot of resources in order to do that.
Yeah.
And essentially what we're doing here is we're replacing local logging with, I assume, HTTP calls somewhere, calls to a REST API somewhere. How does, what are the performance implications of this? Obviously we could probably use these on web services that are not seeing millions of requests per second, or at what level at what performance level can we use this?
That's an interesting question. I don't know the penalty, if I can say it in that way. The thing is that this is such a hot code that I can't tell you. I wish I would have benchmarks at this moment. It's going to be very difficult to create benchmarks for this.
Theo, we might be able to help you with that.
Yeah, that will be awesome. But I will try to explain you why it's interesting to do the benchmarking. Help is very awesome to get, because the moment you start benchmarking a CDI application, for example, with no work in it, your overhead will be 90%.
So we're going to be doing a proof of concept with Datadog, and I was actually excited to discover your modules just a couple of days ago, and we're going to give them a test to the original questioner. How one of the common setups is you put the Datadog agent on the same server as your application, so it's making an HTTP request on localhost. So you're not dealing with any network bandwidth there. The agent then deals with all the network latency and getting the information actually up to Datadog
in a different process.
In a different process,
Exactly.
Cool.
Yeah, I mean, Datadog also provides direct APIs and stuff like that. But for this kind of tooling, the easiest thing is just to have it point at the agent. We already have Nginx. We have an Nginx proxy on each of our server boxes, and we get, on the servers we're going to test this on, we get between 100,000 and 500,000 requests a day per server. So not massive amounts of volume, but interesting. It's sufficient for some analysis. And some of the calls we get take 200, 300 milliseconds to respond, and some take 50 seconds to respond. So there's a good breadth of processing time. And we already have Nginx uptime logs that we use for our metrics right now to look at how long it takes each request. So one of the things we plan to do is sort of be able to compare a couple of weeks of our Nginx upstream logs before and after we put the instrumentation and Datadog in place. So hopefully, if there's anything more than tens of milliseconds of impact, we should be able to see it.
That would be awesome to.
So it's not quite the same as benchmarking, but as far as like looking at actual impact on production code at scale, we should be able to take a look at the statistics.
Yeah. So the approach we at Perceptix will take is that we are going to roll this out soonish on just one production server. Once we are confident that it doesn't hit the user too much, we're going to roll it out on the other ones. So only a small percentage of all the users hitting our service, our system will have that penalty for the first days. But reading up on other people, their blogs you can find on the internet, they say it will have a penalty. It's just a very small penalty. Like you said, it talks to the Datadog agent on your local host. It takes care of it. And this is more or less a huge proof of concept still.
Okay, and
this software is written in a very... Sorry?
I need to interrupt. We're out of time.
Okay.